All right. Good morning, everyone. We're Team Level Up. Here are our instructors, our team members. Okay, so Level Up is a faculty pitch project to support the upcoming level design course starting fall 2023. And we all know that Unreal became one of the industry standard, but it's not really beginner friendly. And it could be quite intimidating for people who first start learning it. And on the market right now, there's a lack of good tools for students. They're not really catered for student users or practice purposes. So our goal for this project is to build an Unreal Engine plugin that serves beginner users and students who want to practice their level design skills. And before we start tackling this big body of tasks, there's some questions need to be answered, such as what are the workflow in AAA pipeline? What kind of tools do level designers need? How do we help designers to speed up the layout process? What kind of assets are good for level design? How do we let users focus on designing instead of struggling with the engine? And how do we simulate the given condition in a bigger production? And to better answer these questions, we started with some research first.
So we start with the research with the level designer first. So we received 32 survey from the survey data, and 80% of them are professional level designer, and we divided them on the relative skill sets, for instance, the programming skills and art skill that can support their level design skill. And also we have a database about most used module in level editor. And here's our outcome that the most used building module will be the terrains and assets, texture and lighting, and the most used custom module that they need to make themselves in the engine will be the level logic module, triggers, function module, properties like destroyable or movable, and also the movement module like the linear and circular movement. So we also connect with experts such as level designer and educator to have like different aspects of our project insights. So the first three of this is the level designer in the game company that we want to know like how level designers think and how they use their professional level editor in their workflow. And for the right side is the professor of teaching the game. So we want to have an insight from the educator aspects on how to educate students to use the level editor much well and use it as their companion with the level design. So, and also we, based on the survey and the expert insights, we design our own character because the default character in Unreal Engine cannot support our genre of the level design, the parkour game, or like the non-combat traversal gameplay. So we designed our character to have a pole, and this pole can support it to do the difference jump and also the traversal behavior and also the interactable actions. So why not we use the hook or boom wrench or other props because they are all like single-purpose prop and cannot be used in a wide variety of the gameplay-based level design.
So in addition to the character design and the survey from the professional level designers, we also want to think and act like a level designer. And our target users are the students who are not familiar with the level design and they have interest to the level design. So we made some levels by ourselves and want to figure out what features they want. So we did a design jam and we tried to add some features of the traversal games and our unique character features in our designs. And finally, we came up with 3 level designs. And our goal is to extract the features from the design and the gameplay level to our toolkit. And we found out that the playable level is very useful for programmers to define which variables should expose to the level designers, and also it will helpful for the level designers to custom their levels. And when we built the level in the UE5 engine, we realized that it really takes a huge amount of time on the things and other other than design. For example, if they want to build some features, they need to write some code and build a model by themselves. And those times should be better to spend on designing and iterating itself. So we're gonna make some pre-made features for them and help them save time and more focused on design itself. So we try to close the gap between the professional level designers and the entry-level designers. And we combine the ideas we got from them and have the following features. The first thing is that the features they commonly used when they build a level. And the second feature is that they want, but the features are not in the UE5. And the third features are our pre-made features they want. And finally, are the features that are easily combined with other features.
So here are some pre-made assets that we implemented. The first is level logic system. We think the level logic system is one of the core elements in the level design. So with our pre-made system, the level designers can, for example, add a checkpoint by just simply dragging and dropping the asset into the scene. And we also made a health system. Basically, it has a health bar for the character and a damage system that will manipulate all damage from the environment. This system can help the level designers control the difficulty of their levels. Event triggers is another key element in the level designs. We have made many functional assets like doors, buttons with event triggers embedded, but we also give the level designers the ability to create their own events by simply just changing some attributes. Interactable assets. To let the character fit with the level and let it use the pole, we have created some interactable assets. For example, the hanger will help the character jump over, for example, a hole on the ground, and this moving hanger will bring the character from point A to point B. So, and the level designer can also combine those assets to create some unique gameplay features they want. Animations, we think the default animation given by the Unreal 5 engine is not enough, especially for a AAA level standard. So we create some animations to let the character fit with the game environment. And those animations can also help enhance the player experience.
Okay, let's talk about art style. So after several research, we found a style called brutalism. And the reason why we use brutalism is it can be easily distinguished from other style. And the second, the assets of this style have a highly degree of uniformity, which greatly reduces the workflow for artists. And the third point is it's very suitable for a large number of building groups, which we want to do at the beginning of our semester. And here's our art assets, work in progress. As you can see, the diverse and interactable 3D assets. And we'll also offer several sample level to tell the entry-level designer how to build a level and how to use our assets. And here's our assets library. So maybe you want to know what's the difference between our assets with the normal model. So first one, we offer like functional assets, just as we mentioned before, the pole, the slider, and the direction assets, like styles, pipe, door, which can help designer to build a point from point A to point B and guide the player know how to play this level. And we also offer like the color codes. The blue means interactable, and the red is destructible. And here's our future plan. The first one is focused on improving and smoothing the animation, which is the most important thing. And the second one is adding more functional assets. And the third one is more instructive level templates and instructive models with shape language.
Okay, so now we encountered a new problem, which is the navigation problems. So as you can see in the left picture, this is our project structure after we made all those assets we mentioned above. So it's not really friendly for the beginner level designer to use. So we want to know how to make a new user interface to really will categorize all those assets we made in our engine. And also there are some assets, for example, character animations. The level designers don't care about those. So, and also we don't want them to edit those animations. So here's our solution. We developed a tool, so this tool has a really easy way to access, which is from the Unreal toolbar menu. So when you click the button on the toolbar menu, it will jump out user interface, and we will categorize all of those assets in our tools. And also in each tab, we have drop-down menus to secondary categorize our assets. But for now, we still have some issues. For example, how to make this tool more easily to use. For example, you can simply drag and drop the assets from the tools into the scene.
So to test the functionality of our toolkit, we have held another game jam last week. Basically, each member in our team will create a level in 4 hours using Unreal Engine, but this time with our toolkit. And here is a video of some of our level.
Okay, so this is our future timeline. You can tell from the orange color, so this will be our main forecast after the half. So basically, we are focusing on more playtest and iterations about our toolkit. And also, we will write some documentations to tell users how to use our tool. And finally, we would like to announce that we will hold a level design game jam before the end of the semester, and we welcome all the ETC students to join us, and also the students from CMU main campus. So this is basically the final big playtest for us to more polish our tool for the future production. Okay, and yeah, that's it. And finally, we would like to thank Dave, Heather, and Chris to help us to connect all those talented people in the industry. Thank you very much.
So is the course you're going to use, if the course is going to use your work, is that meant for non-Unreal programmers? And if so, are you going to test with non-Unreal programmers later this semester?
Yeah, so you don't require to have the knowledge of Unreal Engine, and we'll provide the basic intro tutorial, and also the documentation will be posted online.
So in your game jam, your level jam, April 8th, that's for non-Unreal people?
Yeah.
So I think they need to have some basic knowledge about game engine, so they can, for example, navigate in the scene, so something like that. So yeah, for example, they have the Unity user experience. It would be better to use our tool. Yeah.
Couple of quick questions. The animations, did you guys make them or are they mixable?
We find them on the Mixamo and we make some revise to fit our poll features.
It would have been nice to see that process a little more clearly, especially if you're using someone else's artwork. And then the other question was, what's the plan for evaluating this? And is there any plan to evaluate how effective the actual levels designed are, like how engaging and fun they are to play?
So we have standard to test if we are succeed in our tool making. So Heather have given us some assignment. For example, you need to build a scene like this type of scene in, for example, 1 hour. And if you can use our tool to make it come true, so if you can make a level in 1 hour using our tool, that's our success. Yeah. So that's how we measure our success.
I think our tool is to provide all the necessity for building a good level. It's not really to measure if the level is good or not. Essentially, we don't provide like a standard sheet for if a level is good or not. Like, we're not making a tool that judge that, basically.
Time for one more?
In your documentation, do you plan to include instructions for how to replace animations and artwork, or is that beyond the scope of what you guys are trying to do?
For the animation, it will be building, so you don't need to address your animation when you are building level. So we want you to really focus on your level design, so the animation will actually automatically be triggered when you are encounter some interactable objects. So that's our plan for our design. So there will not be like how to use animations documentations files. Yeah.
I mean, you can change the input mapping, like which button is for jump and which button is for sprint. But other than that, all the animations are embedded with the character.
of 44, that's what it is.
That doesn't look like our slide. Oh no. Oh, I didn't know that. I didn't know that. First timer, sorry.
Unless you want to present level up slides again.
Oh, we can try. So hello, thank you for coming. We are Team Illuminatis from Dynamic Luminescence. Here we go. So here's our team members. My name is Sai, I'm the producer.
Stephanie is sick today, but she's one of the artists on the team.
I'm Jiajie, I'm the programmer of the team.
I'm Koi, I'm also the programmer.
And I'm Chloe, I'm the artist on the team. These are our collaborators slash advisors. Mikhail Ouna is our collaborator, and Marquez Red is the producer on his team. And we have Heather Kelly and Mosh Maller as our faculty advisors. This is the general overview of today's presentation. Our collaborator, Mikhail Ouna, is a Nigerian-American multimedia artist, and his artistic practice ranges from technology to art based on African cosmologies. He utilizes traditional African knowledge systems to erase the boundaries, restrictions, and frontiers beyond people. This is one of his previous artwork. He utilizes UV fluorescent paint and handcrafted UV filter to play with light and luminescence on model's body. And from here, where is our team going?
So I'll be talking about African Igbo cosmology a little bit, which is the entire story of what Mikhail wants to deliver. So there's 4 world ages in this cosmology. The first stage is Wugaga, which means the age of unity and oneness. The second stage is Wugachi, which means the age of awareness and separation. Sorry. The third age is Wuganu, which means the age of sun and like kind of light and civilization. And Wugazi, which means the age of separateness. And that kind of loop back into the first stage. So the 4 stages actually kind of form this cycle of life. And here's sort of the Mikhail's vision for this project. On our team, we're delivering the tech and the art to form this responsive performance. And that will go along with the choreography from Mikhail's side, as well as the music from his other team. And that will eventually lead to this African Igbo cosmology story. So to kind of emphasize, we're only working on the tech and art to form this responsive performance. The other things are covered by his team. And here's like a little breakdown of the tech and art of our project. So for technology, we're using Azure Connect for motion tracking. And then we're using Touch Designer to generate visuals that's going to map onto the performer's body. And then we're using Projector to project those visuals just onto it. And then art side, we're creating 4 sets of visuals, which map onto basically the 4 acts. And then we're telling the story of African cosmology through those visuals. And here's our project goal. We're projecting visuals onto 4 dancers. And those visuals will reflect the traditional African cosmology. And we're helping Mikhail to film this demo, which is going to be around Soft Week. Originally, this project was going to be like a live performance somewhere in like a black box theater, but that kind of shifted, and our current progress or focus will be helping Mikhail to film this demo. And here's some project deliverables. We're delivering like a functional system with like a controller so that his team can easily transition those visuals. And then we're creating those visual treatment in our team as well, so that we can project those things onto the performers. We're also creating source code and delivering the source code all to the Mikhail's team, and then eventually like a user installation manual so that his team can install this piece elsewhere, so like bigger theaters, stuff like that. And it's like a little tech breakdown of what's happening in the whole system. So we'll first have like a bunch of dancers doing their things, and those imageries will be captured by Azure Connect, which generate this raw image from the sensor.
And then this raw image will be processed or sent into the touch designer, which is the software where we will be creating a bunch of visuals. And those visuals will be mapping onto like a mask in touch designer. And this mask will be sent to projector and eventually send it back to the performer's body. And I'll pass it to Chloe to talk about some art we have done.
So these are 4 visuals that we're currently working on for the story of African Igbo cosmology. So the technology behind this is we're currently using Touch Designer for the software, which is a node-based system. For the first stage, Ugaka, we're using Z-axis camera in the environment to create that spiral. And for the second stage, Ugachi, and fourth stage, Ugazi, we're using a keyboard input for the spreading look, the growing look of it. And for the third stage, Uganwu, we're using both Z-axis camera and also the noise input for the dynamicness. So what we realized through the progress was that our project is actually very tech demanding, and that we have to figure out the tech limit and to figure out what we can design around it. So from the quarter, the feedbacks that we received were, first, we have to fix latency, and second, accuracy, which was very urgent. And our challenge was to design around those 2 above, and the last goal would be to create a more innovative design using different materials.
Here comes our first big challenge, latency. So during our test and play around with our first demo in week 2, we found this really serious problem, as we want to project the patterns exactly onto performer's body. As you can see on the screen here, the patterns we project back to their body is not really match what the tester is doing. So this is really a big problem for our project, because we need to project patterns back to dancers who might have really fast movement. And we did research about what's behind the latency. So actually, it came from 3 parts. So the first is from the R0 KNet itself. Actually, its built-in skeleton tracking and body segmentation algorithm has a latency around 100 milliseconds. And the software we're using is actually great. It has a low latency around 5 to 7 milliseconds. We are good with that. And the projector itself is also a big source where the latency came from. It has a latency around 130 milliseconds. So yeah, we need to optimize it. After optimization, wow, we get a latency less than 40 milliseconds, which is 6 times faster than before. So how we did that? On the R0 KNet side, we read our own body segmentation algorithm and reduced the latency from 100 milliseconds to 50 milliseconds. And the touch designer side, we keep it as before, as 5 to 7 milliseconds. That's great. And the projector, we change another new projector. And it's a gaming projector which can reduce the latency from more than 100 milliseconds to less than 20 milliseconds. So currently, right now, our latency is less than 40 milliseconds, which is acceptable and it's good for our project.
So accuracy, another big challenge for us, consists mainly of 2 parts. One thing is you can see here the outline has a lot of noises, and also there are body parts missing and even a person not detected. So the accuracy is generally very low and not ideal because this performance requires higher precision. So regarding these 2 problems, we tried 2 different things. To get a clearer outline, we did basically the same as when we fixed the KNet latency issue, and one extra thing we did is to test it on computer vision algorithms, which worked very well on one single person, but not on multiple people. So we just went back to KNet depth camera with our own body segment algorithm. And the accuracy significantly improved. And for detection issue, we found that fabric really matters because its reflectivity will affect the results. So we tested various fabrics for detection.
And we found that we need to eliminate darker fabrics, such as black jeans. Another piece of advice we got from our quarter is to design around challenges. Like instead of fighting against them, you could probably embrace it. So that's why we came up with adding trails for visuals, which allows more forgiveness of the latency and accuracy. These clips were taken before we fixed the latency issue, so it might seem a bit too much here, but we will adjust the parameters and work with Mikhail to further incorporate into our project in a cohesive way. And next is our visuals in progress.
So this is currently 4 of the visuals out of many that we're working on right now. So not only to serve the spiritual context of our collaborators' artistic practice, we also realized that we have to add some dynamic aspects to it to work with the variety of dancers' movements. This is our short video demo. So currently in this video, we're testing out some abnormal behaviors that we might encounter, such as hopping, walking around, and overlapping. Also, we're testing out some dynamic backgrounds, such as interactive and non-interactive. We're working as hybrid. The big issue we have on these working stages is the calibration, which means we're kind of lacking of accuracy when we get closer to the projector, but we're currently working on it. And this is a fun, interactive background that we're currently working on. So what is calibration that I mentioned just now? So calibration is needed when the dancers or performers are going closer to the projector. This alignment happens because of the Azure Connect's position and projector's position have gaps in between. So our 2 programmers have written a system for computer vision to fix the warp and distortion through projection matrix. So how far have we come from the quarter feedback? So in terms of latency and accuracy, those 2 are vastly improved. And we were able to design around these challenges. So our next stop is to create more innovative and interactive design using different media, such as physical material.
So I'll talk briefly about our next stage plan. So our next milestone will be week 8. From the technology side, we're going to focus on solving the calibration and alignment problem. And then the programmers are also going to work on making the background a little bit more responsive. As you see in some of the videos we have, that's our current progress. And on the art side, we're, again, exploring more materials such as fluorescent paint, reflective fabrics, as well as maybe lighting. We'll see how those experiments go. And the artists are also going to focus on making the responsive background as well, because this is where the stage, programmers and artists have to kind of work together to make sure that the visual is as appealing as possible. And here's our project timeline. Again, week 8 will be the next milestone, and after that, we are going to make changes and fix for week 12. And week 13, that'll be soft week, and then also where we're going to film with Mikhail, so kind of like our deadline. And then week 15, that's where we're going to pack everything, like user manuals, all the codes, everything to Mikhail so that he can, try it in his team and then, for the future. And we're taking a question and answer.
Hey, so a lot of computer vision is notoriously racist because it's used to looking at light people's skin, and it seems like you encountered some of those problems in terms of the dark clothing. Are you planning to think about how those issues will affect your dancers who may be African American or have darker skin?
Yeah, so we do encounter this kind of problem because we are kind of in a dark environment. So the normal colorful camera would not work. So we use the IR camera for the image input. But it's not that, so the output of the computer vision algorithm is not that satisfied, and the accuracy is not that good. So that's why we turn back to the original depth image we have and write our own body segmentation algorithm rather than use a computer vision or AI algorithm to detect the body segment and body tracking. Yeah.
So generally, black skin or like any kind of skin works quite well, but we do recommend like a lighter fabric. So we're using like a grayish, like kind of purplish bodysuit right now, which has the best kind of like visual. But yeah, generally, like through our like fabric tests, it's mostly black jean for some reason that just cannot be seen. So any kind of other fabric would work. We are still working with Mikhail to figure out what kind of costume they want. Maybe they'll have some like custom made like just different things, but we'll see. But that's been a problem we always have in mind.
So are the dancers going to be, okay. Are the dancers going to be performing like a foot away from the back wall, or are they going to be going out into the space? And if they're out in the space, have you considered doing a multiple projector solution, one where one is covering the dancers and the other is covering your background?
Yeah, multiple projector solution was one of the initial thoughts we have, just because we're casting shadows in the back. But due to like budgeting reason from the client side, he only wants one projector. So we sort of communicated with Mikhail, saying things like, you have to be in mind of the fact that projector's nature, if it's too close to the projector, there will be shadow, there will be like distortion, things like that. So he's aware that the choreography has to happen in like a really close space, as near to the wall as possible. So it's basically like it's something that we have to kind of look out for. But I think, yeah, the clients will communicate it on that point.
Can you talk a little bit about the art design for the visuals for the different ages? Did you guys come up with that, or did your client come up with those images?
So our collaborator, Mikhail, has provided us the reference images and reference videos that he would like for those like 4 stages. But in terms of more like detailed artistic decisions and so on, including me and Stephanie, the 2 artists on the team, we have created mood boards to like variety of references, visual references and so on, and adjusted with our collaborator, and also showed him some interactive sketches and so on to create something that's most accurate to what image he has on his mind, but also some fun, dynamic experience for the artists on the team as well.
All right, thanks, team.
Thank you.
Thank you.
Thank you.
Hello and welcome. This is our Halves presentation. So we are Moonlanders. My name is Angelina, the producer. This is Antoine, our assistant producer and designer, Tyran, one of our programmers, Cleo, our other programmer, Jojo, our 3D artist, and finally Derek, our designer and 2D artist. Our faculty advisors are Scott and Shirley. So for this semester, we are working with Mike Hennessy at the Moonshot Museum. So just for a quick introduction to our project, As I mentioned, we are working with the Moonshot Museum. They are a new Pittsburgh-based science and space museum, primarily focused on educating their guests, primarily families and children, about space travel and exploration to the moon. They are partnered with Astrobotics, another Pittsburgh-based company that specializes in making lunar landers, rovers, and other forms of spacecraft. So for this semester, we are working on 3 prototypes for the museum. 1 prototype for each of these specific areas. So one area we have is a theater, which is a theater. Then we have the clean room, which is where Astrobotics assembles a lot of their lunar landers. The habitat, which is an area in the museum with some seating, a table, and some screens. Plus, we will be making documentation to accompany each of these prototypes. So the first problem that we ran into immediately out of the gate was scope. We are making 3 prototypes, and we initially had some very ambitious ideas for what we wanted to do. However, quarter's feedback revealed to us that we were maybe a bit over scope for this semester. So our first challenge was figuring out how do we want to reduce the scope of this. So what we decided was first, we were going to focus more on the experience of each prototype rather than focusing on making innovative technical solutions. Secondly, we are not delivering final installation-worthy products, but we are treating each prototype more as a proof of concept. And finally, for each of the prototypes, we reduced the number of mechanics and simplified on what type of mechanics we are including. Now to talk about our first prototype is Derek.
Right, so payload packing, or finding space, as we've lovingly named it. As Angelina mentioned, the clean room is a great spot for museum guests to get a good look into Astrobotics' world, so what they're constructing, what they're developing. The challenge that our team was presented with is that it's not always as full as it is now. What you're looking at is the Peregrine lander, which will be the first American lander to touch down on the moon since the Apollo mission. That's obviously really exciting for guests, but sometimes the clean room is empty. Sometimes it's in a state of work that is not as readily visually readable. So our challenge that we gave ourselves was to try to fill that gap a little bit, to give guests a taste of the final state of things, even if the room isn't as full as it is right now. So with that in mind, our current experience is an arcade-style crane simulator, basically. Guests will load payloads onto the Peregrine lander, and success will be measured by fulfilling mission manifests and balancing the lander, which is important to Astrobotics in real life. So as far as payloads go, we wanted to make this educational for guests. We wanted to base it off of real-life payloads. These payloads can range from academic and scientific payloads, such as NASA's Fluxgate magnometer, which I'm sure we're all familiar with what that does, or CMU's own MoonArc. And they can also be more commercial in nature. This is Pocari Sweat's Lunar Dreams project, which takes a pressure vessel that looks like one of their drinks. They filled it up with messages from children around the world, and they're going to take a picture of it on the moon. So when guests interact with payloads in the space, our UI will pop up and give them pertinent information, the name of the payload, the weight of the payload, and then a short description. So this is the model of the payload, of the Peregrine lander that they'll be loading. When creating the design for this model, for us it was about balancing the realism and a more stylized approach. Obviously we want to give guests a sense that they're looking at an accurate model of the Peregrine lander, but we found through playtesting that more exaggerated features could help the readability of the experience. For example, during our playtests we found that guests wanted to load the payloads on top of the lander, which is where the solar panels are, which is not very great for space travel. So we took the payload platforms and we enlarged them and we painted them the same color as the crane, which really helped guests connect the dots. So to talk more about playtesting is Anton.
Thank you, Derek. So we wanted to learn how engaging and satisfying our payload packing prototype is to play. And based off
prior user observation, children are not afraid to test the limits or experiment with an interactive exhibit to discover all its affordances. So we wanted this prototype to really empower this form of experimentation whilst still providing a clear goal for the guests. So having conducted our first round of playtests, we learned that guests really enjoyed the feeling of operating the crane. They found it satisfying to accurately place down objects on the lander, and they also liked knocking towers of cargo over that's ready to be loaded. And in terms of negative feedback, they didn't like rearranging cargo that had been or placed on the lander by them already because they didn't notice the balance UI that we'd made for this. So our next immediate actions were to make a UI that was clear and conveyed the information of what the guest was loading, and this is where the learning will take place. And here is a demo video of what we have achieved so far. So as you can see, the balance UI at the center is a lot clearer. We also have an image on the left displaying what the guest is loading, along with statistics and an overview on the right. And our second prototype is the AR Moon Colony. And we are setting this in the habitat area of the Moonshot Museum, which is meant to simulate what a living space could look like in a future residence on the moon. And we are drawing inspiration from the visualization of a moon village created by the European Space Agency in terms of aesthetics and infrastructure. And we are drawing inspiration from the mechanics of sandbox games. Now, for example, we want to teach guests about how a colony operates and the necessary components or infrastructures that are required for that colony to thrive. So, for example, if a guest were to add a solar panel to a scene containing an engineering facility and a greenhouse, they would now have power and they would also have food, seeing as photosynthesis can now take place. And the colony, now that they are properly sustained, they are able to create technology such as robots or rovers which can go out and collect ice, which can be transformed into water. And a big design challenge that we've faced so far with this experience is enabling guest turnover to be as easy as possible. We want people to be able to come and go for as long and short as they want. And we wanted to achieve this by making the controls as simple as possible by just using the joystick and trigger button on the Tilt 5 controllers, and therefore making the tutorial UI as minimal as possible and always having some buildings working in synergy in the scene already so guests don't, they can start experimenting immediately by dragging and dropping, adding and removing, and seeing what that produces. And now to talk about the 3D art, I'm going to hand you over to Jojo.
So for now, we have 4 types of building. In order to make each of them look distinctive but not too unique, they are all using different shapes with shared elements such as entrance and the decorations. The design of greenhouse allows guests to see some parts of the plants but also not expose the plants too much, since the plants cannot be exposed directly to the atmosphere and sunlight on the moon. Here are also objects that's going to be generated by the buildings in order not to make the moon colony visually too busy and chaotic. Mike and we agree that the art style should be cartoony, keeping everything concise and cute. So in this building cluster, we can say there are radar dish and gardens on the residence units because they are near the greenhouse and the engineer offices. The more engineer offices and the residents, the more astronauts, robots, and rovers gonna show up on the grid. 3 residence buildings will generate a garage with 3 solar farm panels. 3 solar panel farms will generate nuclear plants, which will light up the nearby buildings, such as engineer office and residence. And Tyron will talk about the Tilt 5.
Thank you, Jojo. So the reason why we chose Tilt 5 as our ideal platform, because it provides 2 main advantages. The first of all is the well-known ability of AR for enhancing the learning experience by blurring reality and the virtual world. The second, of course, is the unique
is 205's own unique features. Because it came along with 3 controllers, 3 glasses, and a board, it is the perfect platform to create a joint experience for a joint tabletop experience, such as a board game or a sandbox. As the engineers of the team, our mission is to help the designers to verify their designs. So, and also explore future technical solutions as far as possible. So we identify several what we call infrastructures mechanics in the game, such as customizable hexagon grid layout. The reason why we chose hexagon is because it's not only because it is more visually appealing compared to normal rigid square layout, but also it has a more accurate depiction of the neighboring cells, accurate depiction of the distance between neighboring cells. And also we have a traverse functionality for picking and selecting and picking and building things on the layout. So as you can see, we use downward Bezier curve as our cursor, is because the virtual terrain is actually a little bit below the tabletop, so we think it's very natural to use such a curve, and also it produces a very accurate result. Last but not least, we have a navigation system on the grid, because we envision that in the future there should be some NPC characters like rovers or robots that just working on the layout. So we think it's very crucial to add more spice to the game. Next, I will hand to Cleo to talk about our final prototype.
Thank you, Tyron. So now we'll talk about our third prototype, Mission Control. This is an experience designed for the theater in the Mensha Museum and is inspired by the actual mission control that takes place just a few rooms away in the Astrobotic building. It will be an around 15-minute interactive experience, and the guests will need to work together to complete the mission. To accommodate a flexible guest amount, we decided to split the guests into 3 different roles. There will be a communication team, a mechanical system team, and a payload team. And a facilitator will act as the flight director to give out commands to and move the experience along. Currently, we are more focusing on the previous 2 prototypes, and we'll work more on the interaction and gameplay for this experience after half. So looking ahead to our timeline till the end of the semester, we'll wrap up our development for payload packing this week and move our focus to the other 2 prototypes. For the moon colony, we will start adding in more game mechanisms and upon the infrastructure that we built so far, and we'll start the development for mission control simultaneously. A few weeks before soft, we'll take back all 3 prototypes and add more details to it. From soft to final, we'll start our refinement and also work on our documentation. So in summary, we are the Moonlanders, and we're building 3 prototypes and documentation, payload packing, a moon colony, and the mission control for our partner, Mensha Museum. A special thank you to Astrobotic, Mensha Museum, our playtesters, and Till 5. Thank you, and we are now open for questions.
Yeah, I don't have a strong sense of, I think the prototypes look great, but I don't have a strong sense of where they will be, how they fit in to the experience and the overall kind of service design of things. Can you talk about that a little bit?
So each of these prototypes are designed for a specific area in the museum, and while in the museum as a whole, there is a sort of, in field trips especially, they have a mission structure that goes set of like connected missions that connect each of the activities. However, our prototypes specifically are designed for experiences that will be separated from those mission structures. So for example, if in a field trip, the students might have some downtime between when they are doing one other experience and another experience, and that downtime, they might come to one of our an exhibit based on one of the prototypes that we are developing, and sort of interact with that during that downtime, basically. So it is designed to be separated from the currents or structure.
Could you talk about the planned experience length for each of these three pieces? Because like the moon colony can get really complex. And also if that's cooperative or competitive, because there's three at once, right?
So we plan for the moon colony to be a cooperative experience, and guests are, through experimentation, are encouraged to see what happens when they add certain bits of infrastructure to the scene. In terms of length, as we said, with the moon colony, it's meant to be easy for guests to come in and out of the experience by having no specific end state. They come on, they see what happens, and then it should be as easy as possible for them to just put down the glasses and hand it over to someone else. And in terms of average experience length for what we envision the payload packing being, it's about 5 minutes as well.
So designing prototypes to answer questions and being sort of specific about that is a challenge, and I'm kind of curious if, from your experience with the first two, if you've revised your plan for the last one to be more focused and sort of be more testable to get clear answers. Basically, have you changed your process for prototyping for the last one based on your previous experience?
Yeah, I can answer that. I think what we've taken away from our previous playtesting is get stuff on the board as soon as possible. So for mission control, our plan is to basically play storm, to get something written down as soon as possible. That's what we've learned, because on previous iterations, we've taken too much time to make something perfect, and that's what we've learned to stay away from, because there's always changes to be made.
I just have a random factual question. Why can't plants on the moon be exposed to sunlight?
Well, I think I did some research to ask about whether the plants can directly planted on the soil, and apparently they need to nurtured in a lab environment, and obviously the environment on the moon is not really quite good for plants, because they are only available growing some like really small plants on the moon. So that's the fact I researched about it.
All right, thanks, team.
In the near future, plastic pollution starts to become fatal to mankind. A group of scientists developed a type of genetically modified plant that consumes plastic, hoping it would eradicate the crisis. However, the experiment goes wrong and the overgrown plants end up consuming more than they should.
Good morning, everyone. We're Team Vita Animation with our half presentation. So this is our team with our roles on the screen. We have Jason, Shen, I'm Jackie, Yuxi, Dennis, and Ryan. And these are our wonderful instructors who provide a lot of help throughout the progress. So as our team name suggests, we are an animation team, and our final goal is to deliver a 3-minute animation video by the end of this project semester. And our high concept is to raise the awareness of plastic pollution, and our target demographic is PG-13. This is a pre-production package given to us. Basically, we're going to produce the animation all based on this pre-production package generated by AI. This is some screenshots. It contains a lot of stuff. This is the general pipeline that we're going through. So basically, our artist creates models in Maya and Blender, and then based on specific needs and their skill sets, they use a lot of other other softwares to do rigging, texture, and like procedural generations. And then we put everything into Unreal, and we do the lighting, cameras, and the rendering there. And then we output the image sequence into Final Cut together with audio, the sound effects and music edited by Logic Pro. And then everything combines together in Final Cut, which is going to produce the final piece. So we're initially using just a Google Sheet to manage our assets. And then later on, we switched to a software named ShotGrid, which provides a very efficient interface for our artists to upload their work and get feedback from our instructors. And next, Yuxi is going to talk about our story.
So I'll first tell the story in chronological order. So we start with a news broadcast. Basically, the lab Waste Not will announce that they are looking into the possibility of genetically modified plants that can consume plastics as a potential pollution for plastic pollution. Then we go into the development of the plants, so lab setup, pruning the plants, and then modifying their DNA. And then soon after, we have our first moment where the plants are starting to respond the way the scientists intend. So they're starting to actively search for plastic around the environment. And then after that, soon after, these plants start to get out of control in the sense that they are not only just looking for plastic, but they're starting to look for microplastics, which are found within our bodies as well. So as these scientists try to stop these plants, they get killed in the process. And then we jump 3 years later, and we see this overgrown lab that is completely destroyed and covered with these plants. But our largest storytelling challenge with this is that we plan to tell this backwards. So essentially, we have 2 time periods in this animation. We have current time, which is basically the 3 years later when the lab is fully overgrown, and then we have flashbacks, which are instances of when the plant was being developed. And throughout the animation, we are panning through the current time, so we see the overgrown lab, and at certain instances, we will pause at a shot and then flash back to what happened 3 years earlier. So in short, if you look at this green bar, this represents the current time, which happens throughout the animation, and then the flashbacks are happening in between. So for example, in that first shot you saw, we panned to the skeleton, then we would flash back to when the scientist is killed, and then return to current time, and then pan through the environment again. And these flashbacks happen earlier and earlier. So basically, the first flashback we see is when the scientist dies, and we keep backtracking until the last flashback shows the news broadcast. And we hope that with each of these flashbacks that the audience will get more and more clues about why the lab is so overgrown, until finally, in the final flashback of the news broadcast, we get that aha moment. And now I'll pass it to Jason.
Okay, so for our progress since quarters, we have finished 2 iterations on our storyboard. We have completed 3 iterations for the animatics by this week, and we completely finished 1 scene for the animation, which is the first scene. And as for sound effects, we add all of our sound effects to the animation in Vegas Pro, and right now we have finished adding all the environmental ambience and all the one-shot sound effects for the first two scenes. How to use the audio to actually connect the past and the current state is a challenge for us. And we want to begin with these two scenes because there is transition in time between those two shots. And figuring out how to handle the audio for this transition will actually help us, give us a good reference for handling the time transition in the rest of the piece. And in the future, we will be finishing adding putting all the sounds in place, and also we want to have time for recording the voiceovers. And next, we have music, and all of our background musics are composed in Logic Pro. And we currently have completed music for one important scene that is, that scene can be considered as an emotional high point of our animation. And when composing the music, we first need to analyze what is going on in the scene and what's the general emotion of the scene, and let the general emotion decide what kind of color should the music have. And in this case, the challenge brought by like the jumping back and forth in time is even harder to deal with because too much drastic changes in the what is happening on the screen will actually kind of destroy the general emotional flow of the music. So right now, we have, our solution is that we want to have mainly sound effects for parts that are too dynamic and leave enough room for the music in scenes that are long enough and emotionally steady. And in the future, we'll be keep expanding on what we already got and finish the background music. Next, I will pass it to Yuxi to talk about the characters.
So we have two main characters other than the plants, Ozzy and Mel, who are the scientists that are developing this plant. And we received AI-generated art references for the foundation of our character design. And our main challenge with the characters is that we really want to convey that feeling of pain they have when they're getting strangled by these plants. So since we don't have any skilled riggers on this team, we decided to opt for MetaHuman. And MetaHuman is a Unreal Engine software that allows you to customize human models, and they come with a very complex facial rig. So this is the rig of our scientist Mel, and as you can see, the facial rig is very, very detailed. And we hope to really take advantage of this to really push the emotion of like fear and pain throughout the animation. And then we used advanced skeleton in Maya to get the body rig. Since MetaHuman is very realistic, we decided to use ZBrush to get the clothing details to be also emulate that realism. And this is just a draft shot of kind of the level of detail we want to have in our facial expressions. And since we have the foundation of the characters now, we hope to spend the rest of the semester working on solely animation. And now I'll pass it on to Dennis.
Thanks. So this is the first scene we show you at the very beginning of our presentation, and it helps us to get a better understanding of the overall workload pipeline. So we started with modeling and texture in Maya and Substance Painter, and rendered them in Unreal Engine. At this point, we finished most of our assets, like the 3 skeleton binding with the vines. This process gives us a confidence of finish this project in the rest of this semester. So later on, we will more focus on the character animation. So why are we using Final Cut to editing? The reason is simple. Since we need to figure out, we need to update our animatic every week. And Final Cut is the most easiest way to do so. So right now, we have finished the working animatic and already have 3 iterations of it so far. We will spend more time later for the post-processing, color adjustment, and transition effects. And next, I will give it to Shen.
My responsibility is the plant groups, because plant groups actually serves as a very important character in our story. So my biggest challenge is how to bring life to those to those plants. Firstly, I designed the whole plant group as a tropical ecosystem, a rainforest look like. Then, as you can see, there are 2 hero trees. They have different characteristics. One plays as a center support of the destroyed lab. Its tentacles tries to take over the whole lab, and the other one grows on the side of the lab. Its tentacle twined around one of the scientists, killed him, and grew together with his dead body. To strengthen the power of the plants, I thought a lot of the details of the structures. As you can see, the floor, it contains different layers, the surface panel, the inside steel beam system, the ventilation system, and the ceilings. To add more details to the trees, I use ZBrush to model them. That's how it looks in Unreal Engine. In the next few weeks, I will use different techniques to bring a more vivid plant group to our animation, like Houdini generation. Next, Ryan will talk about the hard surface model.
Thank you, Shen. And let's look into how the laboratory is going to be developed. So, to research on how a laboratory is actually built, we'll look into existing laboratories and also concept arts. Imagine a laboratory is going to be crawled with plants surrounding it. There should be something for them to climb on. So frames and also tubes are two main directions we look into when we're doing the research. And also if you come with a color palette during the research, having 5 colors, white, green, yellow, blue, and gray, meaning scientific and liveness. And after doing all the researches, we started to build models in Blender to figure out the sections, the functionality, and also the structure of the laboratories. And we've come up with a floor plan, as you can see on the screen, showing all the functionalities and details and the arrangement of the laboratories. And after finishing all the models, we imported everything into Unreal to do the cinematics and also the cinematic shots using the sequencer. And we render out all the frames and put it into Final Cut to do the final editing. After finishing that, we use Substance Painter and a Substance Designer to do all the textures. And according to our story plot, we need to have different timelines, which means we need to have a set of textures for all the objects according to their different time status. And also in some cases, we need to have a set of models for certain objects, depending on how severely they are going to be damaged. And on screen, this is one of the example of a box, having three different status according to their different time status. And also, this is another example having 4 status of a light tube. Why there's another more status is because of its own property, as is whether it will be damaged or not in the future. After finishing all the textures, we imported everything into Unreal Engine so that we can do the lightings and the rendering together in Unreal. And this is currently what you have. You can see on the screen how the laboratory looks currently. And that's all for our presentation. And thank John and Ruth and everyone who helped us during the production process. And if you want to check our full animatics, you can please visit our website. And that's all. Thank you.
So backward storytelling is pretty tricky. How are you guys handling the transitions between the different scenes? Like, just talk about your transition design.
So right now we will have glitching effects and also color, like changing of color to show 2 different timelines. And that's the way we use, and we will like have another, like maybe develop for another ways to make it more clear.
And along with that, between the 2 timelines, the environment will be like drastically different. One will be fully overgrown with plants, and one is kind of a clean lab. So we hope that will help as well.
And also there will be a really kind of great contrast in audio since like the scene the scene before will be mainly about environmental sound, and the scene after the transition, like back in the past time, will be all sorts of alarming and mechanical sounds.
So it sounds like you're making smart choices in regard to music. How did you design the sounds that the plants make?
So right now, we are, in my opinion, we're trying to create a kind of dangerous image to the plants. So actually, I'm using a lot of sounds from animal to the plants, such as like snake when the plant is like sneaking on the ground. And for like when the plant is strangling the person, I'm kind of using the something like dragging and leather, kind of that sound for mimicking the sounds of like people getting strangled and the bone getting broken.
So my understanding is the plant is very active, like in some of these thoughts where it's attacking. What is your plan for animating the plant in a very active way? You showed some examples of like time-lapse, almost like growth, but I'm curious what's the, aggressive plant attacking humans animation strategy?
So right now we have two ways. Like we did the animation in Maya, and we are using curve tool and parent them to the joints. So that's a technical way in Maya, and we are also using Houdini to generate the growing effects. So the plant and vines are also our main character. So we are treating them as one of the other two. We have total 3 main character for now. So also counted as the plants.
And also texture-wise, we will decide for example, the tree, there will be texture showing that it has been grown burstly. So the texture that will show that it's being stretched, showing that it just growth out. Yeah.
All right, that's time. Thank you.
Hello everyone, we're Danceology. Welcome to our Halves presentation. So this is our team. I am the producer Xiaoying, and our engineers are Angela, Yiming, and Jason. And our artist is Christine, and our UI UX designer is Xueying. And our instructors are Shirley and Ricardo. And now I will give it to Jason to introduce you to our project.
Hello? Yep. Our client is the Paul Taylor Dance Company, which sits in the center of New York City. And Paul Taylor Dance Company was originally created by Paul Taylor in 1954 and has been a leading force in modern dances for over 6 decades. After Paul Taylor passed away in 2018, the company continues to preserve his legacy through performances, educational programs, and archival works. So we are currently mainly connecting with Michael, Caroline, and Josh on their requirements. Talking about requirements, our client requested us to create an application that can primarily increase public dance literacy, as well as awareness and appreciation on modern dances. Besides, they also requested the application to serve as an educational tool to show the significance, history, and importance of the dance company. So based on that, our target audience are the general public that have little dance literacy. So in specific, the people that have little understanding about modern dances would like to know more about the dance company itself, and people that are open to personally experience the dances on their own. Currently, the main experience that we're working on is the back exercise. The back exercise is a 30-second long exercise created by Paul Taylor himself, and it is very important because it addresses on the fundamental dance philosophy of Paul Taylor, which is the use of back and spine during the exercise. And it is the only official exercise that Paul Taylor created to address on this concept.
Next, I will pass to Xueying to talk about our deliverables.
So our team built a guided interactive single user application that teaches people how to do the pole tailor back exercise. It helps to develop an appreciation of the art form, and also by giving them the opportunity to learn and perform the core dance exercise. So we did research on these game experience and found out two important key takeaways. The first is the visual clarity. We have to make the interface more clearly to let the users understand. And the second is the user feedback. We need to learn what kind of feedback we should give the users so that they understand how accurate their current poses are. So here is our user flow. So first you open our application and there's a welcome page. It says, welcome to the Danceology. And then you hit start to select the back exercise. And then you can choose your level 1, 2, 3. And you set your camera goals and you're all ready to go. Next, I will hand to Xiaoying to continue to talk about our user flow.
So once you go into our experience, there's 3 different levels. The first level is a guided experience, and the second and third level are both uninterrupted. So for our guided level, we want to focus on having the user go at their own pace and actually learn the moves. So we would pause at each pose until the user gets it. And also for this level, we want to focus on the educational value. So we will provide clear visual feedback as well as audio feedback to specifically tell you how you're doing and how do you correct it. Also, we want to have environmental and also visual guidelines to show the forces visually that the dancer is feeling. So for our uninterrupted level, we would increase the speed and difficulty from the second level to the third level. For this design, we want to give the user a sense of progression and accomplishment. So now I'll play a demo for our uninterrupted level.
Welcome to our exciting new experience where you can dance like a professional dancer. For this experience, you won't need any controllers to play. All you need is your webcam and you are ready to go. With our cutting-edge deep learning model, we can accurately track your movements and match them to an original video. You will feel like you are dancing right alongside our talented performers. But that's not all. We know that not everyone has a big screen to play on, so we have made our experience flexible enough to work with just half of your body. And if you don't have a webcam, don't worry, you can still enjoy the experience without checking your pose. We also provide real-time feedback through our score and accuracy bar, so you can see how well you're doing and strive to improve your moves. Whether you are a seasoned dancer or just starting out, our experience is perfect for anyone who loves to have fun and get active. Our team members show you just how much fun you can have with our innovative dance experience. Get ready to dance along?
Okay, I will talk about our playtest summary. So we had 2 playtests in Han Library where we cooperate with certain playtester. We receive a lot of valuable feedbacks, and I would like to share the top 3 feedback with you. So the first thing is that our playtester find out it's hard to see the screen clearly when they were standing too far, especially on the small screen. Therefore, we have added more camera mode to help the player see the screen. For instance, we have a half body mode to help the user using a laptop screen. The second is that our animation is not always clearly enough for our player. Although our animation is generated by machine learning model from an original video, it still got some noise. Also, the lighting right now and the test art make the user hard to distinguish the models from the background. To address this, we adding a tone shader like the right side and a future pose to assist the user in understand what they need to do in the future. Also, we will perform
data cleaning and adding some constraint to help improve our quality of the animation. The third one is the user feedback. Some players say that they are not engaging enough and lack sufficient feedback. So we add some progress bar and region effect on our UI to help our player feel more engaging in the experience. Yeah. Next, I will hand to Christine to talk about the art.
Thank you, Yiming. So this is our current progress of our 3D character model. We've been creating this character model based on Iren, one of Paul Taylor Dance Company's dancers. We're going to use this character model as our teacher throughout the experience. So this is the closer screenshots of the face. We're aiming for animation and stylized style, but based on clients' requests, we're going to keep realistic body proportion of Iren's body structure. So, and for the background, we're going to have 3D environments to visualize the imagery of dancer's mind. To be more specific, we visited Paul Taylor Dance Company in New York, and we had the opportunity to talk with the dancers about how they feel throughout the dance. So they mentioned about they feel like they're moving through the water or even experiencing temperature changes of their bodies. Also, we're going to have visual cues or visual effects to show energy and forces of the movement. This is to help the users to better understand while they're learning. For example, arrows can demonstrate the stretches of arms and legs, or there could be a string pulling from the top of your head. Next, Angela will talk about technology aspect of our project.
All right, thank you, Christine. So you got to look at our demo, and so we're going to pull behind the curtains and show how we're actually implementing this. So a majority of the technology that we're using is pose estimation and tracking based on a machine learning model. What this means is we can take any image or video, put this into this machine learning model, and what it does is it actually parses the image, looks for the person in it, and identifies each of the key joints, so like where the hand is, where the leg is. And once that's been done, this model will then output data that tells us exactly where each of those joints are. So the benefit of using this technology is we don't have to use an external hardware technology such as the Kinect. We can just use a webcam and parse the data there. Now that we've finalized that we're going to be using this type of technology, our first step during the semester was actually doing a lot of research. So there are a lot of different variants of this tool, and each come with their own benefits and drawbacks. So to highlight some of the research that we've done, we looked at many different models and ran it on many different types of dances and poses to see how they were doing. So for example, we took a look at OpenCV, OpenPose, and so on. For each of these, we evaluated various features that were important to us, such as which would be the fastest, which would be the most accurate, most detailed, and so on. After considering these factors and also how they will integrate with the rest of our application, we settled on using OpenPose for the majority of our implementation. Once we've defined our model, we went into implementation of the actual tech. So the first thing we had to do was be able to process a reference video, and this is the 3D model that you saw moving before. What we're doing is we're taking the back exercise video done by one of the actual dancers at Paul Taylor, fed this through our model to generate a pose tracking data for whatever movements they're doing. And once we have that data, we had to figure out how to extrapolate that and apply it onto a 3D model. And so what you see here is the very bare bones method of just taking that data and putting it onto our model to move each of the joints. The second part of our technology is processing the user webcam data. So when a user is actually dancing in front of a webcam, how do we know what they're doing? So what we do here is take in the webcam input, and again, put this through our model to acquire the actual tracking data. Once we have that data, we can then compare it to the data that we got from the reference video and use that to do better pose estimation on what you're doing and also provide you with more targeted feedback. So since those are our main two pipelines, there are also other key algorithms that the tech team has been working on. So the first thing is, what you saw from before was just the raw data that was outputted by the model. It's not always perfect and sometimes can have glitches. So what we definitely need to do is clean all of the data points, denoise it, smooth out features, and so on. Another key algorithm that we've been working on is how to match the user and reference poses. As you know, everyone's joints are different, everyone's a different height, so how do we make sure that we account for those? And one way that we're doing that is making sure that we're not just accounting for distance between like your arm and your elbow, for instance, but rather the angle between them, because that can be mapped regardless of your height. The third thing that we're focusing on is presenting more customizable feedback. So now that we know the position of each of your joints, we can tell you exactly where to move and what to focus on. In summary, what we're providing is an interactive single-user application that's main focus is to promote the understanding of dance performance by teaching the Paul Taylor back exercise. We're doing this by hitting our clients' 3 requirements of achieving dance literacy by using visual and auditory effects to better communicate what the dancer is actually feeling to a naive audience. We're increasing dancer appreciation by having users actually perform the dance and feel the difficulty of the movements by themselves. And we're promoting the historical significance of the Paul Taylor Dance Company by teaching this traditional exercise and also providing educational points throughout the experience. Thank you very much for listening, and we are now open for questions.
Yeah, the animation output in the open pose slide seemed to look better than in the demo. In the demo, there's maybe the transformations of the root is lost or something. Can you talk about that? And is that a problem that you're addressing?
Yeah, definitely. So right now what we have is still very much a demo. We still need to adjust parameters depending on the final model because the dimensions of that is different from the one that we're using in our demo. Part of that is also that we're trying to strike a balance between smoothing out the data, but also making sure that key poses are still hit. That was one of the feedback we've been getting from our clients. So our focus right after coming back from spring break is to focus on cleaning that data and achieving that precision that our clients want.
Is the plan to release this for people to download on their home computers, or is the plan just to have this be a prototype example by the end of the semester?
So the plan right now is for it to be a complete project, and the client will use them in their lobby and also right before the show. So the audience can interact with it in the lobby.
So it will be a standalone application, but it will be in a fixed environment that our clients are able to control.
I heard in your intro video you did mention that it could be played seated. I guess that's great for people that have mobility problems. Could you talk a little bit more about that and like how you address that and like especially like how the game rates your accuracy if you're not performing the full movement?
Should I talk? Okay. Yeah. So essentially, we're putting more focus on like the accuracy within your upper body. So I guess for the full body experience, we're measuring accuracy throughout all of your joints. And the only difference that when we're doing the half one is that we're focusing on like mostly like your arm position and maybe more of your head position. So it's just tweaking the thresholds to get a more accurate experience for that side. Yeah.
Time for one more.
From your interface, it looked like the application was potentially extensible in the sense that you could add other exercises to it. Is the idea that the dance company will then be able to add other things to it after the end of the project?
That's a really great question. So we've been designing our application such that it would be potentially extensible. Our main goal for like the final deliverable is to fully polish this back exercise. So that's what we're going to focus on. But like the design from the tech side is that eventually they would be able to upload like their own, for instance, JSON file that was outputted by the model and then be able to still run that as a customized level.
All right, thanks, team.
Awesome, thank you.
Good morning, everyone, and welcome to the last Halves presentation of the semester. We are Team Story Studio. My name is Lori, and with me are Damien, Felicia, Lauren, Yan Yan, and Randy. Our instructor is Ruth, and our clients are Anne and Debbie from the Children's Museum of Pittsburgh. Now, Team Story Studio is developing a tool that can be used to facilitate interactive storytelling at the Children's Museum. In particular, we are planning for this experience to be in the Grable Gallery in Museum Lab, which is a separate building in the Children's Museum's space. And these events are going to host between 50 and 100 people at a time. To clarify that a little bit further, our clients would like us to take existing storybooks and, using our tool, generate content for an interactive storytelling event. And our team has narrowed this to taking children's books that have relatively simple 2D illustrations and using our tool to create the digital content for an experience. Here's a piece of concept art that kind of illustrates what our team is envisioning for the event. As well as the digital content, our team is producing prototypes of physical interactives for the Children's Museum, as one of the main objectives is to combine the physical and digital interfaces to make this exhibition or event more interactive. Importantly, our team is kind of creating a toolkit and prototyping these components. We are not going to be permanently installing this, nor are we actually going to be facilitating the event ourselves. And in that sense, this project is sort of half exploratory and half deliverable. To illustrate what we mean by the digital content output of our tool, we created a prototype in PowerPoint and play tested that with this class of first graders. The final version or final output of our tool will be very similar to what you see here, except that we envision all of the different changes that you see on the screen to be caused by interactions by the children or by the facilitator kind of orchestrating a larger interactive with the group, as you see in the video. And now I'd like to introduce Lauren to talk about our stakeholders.
Thank you, Lori. So our project has 3 main stakeholders, and these are the content creator, the storyteller, and the audience member. So the first person is the content creator. The content creator is a high schooler or a museum employee that uses our tool to convert an existing storybook into an interactive storytelling event at Museum Lab. Now, this is a look into the guest experience for the content creator. So the content creator would go into the Story Studio engine, create a new project, and if they would like, they can import things like audio files or images that they want to use in the experience. Then they can use our tool to add things like basic animations, sound effects, or other interactions like arcade buttons or Arduino sensors or audio visualization. Once they're done creating their own interactive event, they can preview, save, and export the file. So this is a look into what the content creator tool is currently looking like and some of the features that we have built already. So currently, you can import images or audios. You can drag the image onto the page, add interactions like button or Arduino, adding new pages, and finally exporting the file. Next up, we have the storyteller. Now, the storyteller is a museum employee that will take that executable file from the content creator and use it to put on a storytelling event at Museum Lab for 50 to 100 people. Finally, we have the audience member. The audience member is someone visiting Museum Lab, age 3 or above, who is listening to the story and is able to interact in the event when they're prompted by the storyteller. Now, our project has 4 main deliverables. The first is the beta level tool. This is the tool that the content creator will use to create the interactive storytelling event from the existing storybook. The second is prototyping different interactions. So this is testing that our team is doing of finding out the best ways of engaging the audience. So these are things like the arcade buttons, the Arduino sensors, and the audio visualization. Next, we have documentation. This is a write-up that our team is doing that is explaining our design process and also instructions for how to use our tool. Finally, we have a demo story. This is an example of a storytelling event created by our tool that can show all of the different abilities within our tool. Now, to hear a little bit more about the beta level tool, I will pass it to Yanyan.
Thank you, Lauren. So as you can see, this is our feature list. We've done many playtests trying to figure out what's the actual feature we need in our tool. So we don't want our users spending too much time learning this new tool. So comparing to those classic content editing tools like Premiere and iMovie, we decided to get rid of the timeline and focus more on the interaction. Both digital interaction on the computer and also the physical interaction using Arduino. You can see that some of the features has been canceled out. It's because that in the process of testing, we found out that there are some powerful free software that can finish this job pretty well. So instead, we made tutorials for these softwares, one for image editing and one for audio editing. And we've also done playtests to see if these tutorials are practical and good enough. And we are also planning to implement this sound effect library in our tool. It's because that originally we already include some text materials and image materials in our story. So we want the content editor can use this audio library to make the interactive story more mimic. Now I'll hand it over to Felicia.
Thank you, Yan Yan. I'll be introducing UI iterations. Our interface aligns with the content creator's workflow in our feature list. We're going to develop an intuitive and minimalistic interface for our content creators to put up events. Our team has created 3 different versions of UI. This is our first iterations. Throughout the playtest, we learned that our users are really overwhelmed by the toolset available within our software. They're also confused with the timeline feature, as Yan Yan mentioned earlier. As a result, we refined our UI throughout the playtest to eliminate the confusions by replacing the timeline feature with click and apply features. It reduced necessary steps for our users to apply a visual or audio effects. Then we playtest our second iterations. Users feel it's easier to learn and use our tool within this UI. However, they still needed help with the drag and drop import functions due to a lack of consistency within our UI systems. They also prefer fewer description and more icon within this UI. As this consideration in mind, we developed our third UI, which is focusing on a higher consistency of story design systems. We're looking to playtest this version and iterate based on the feedbacks. Thank you, and now I'll hand the microphone to Randy.
Thank you, Felicia. So to talk about prototype interactions, we need to come back to the storytelling event. According to that 50 to 100 people join into an interactive storytelling event, we can only focusing on this projection screen. We need to introduce more different kind of interactions into our space to let every participant become part of the event. We did different approaches here. So the first one is Arduino. By using Arduino, we can introduce different kinds of sensors and servo into our event and let the kids interact with them. Here is a demo of using ultrasonic sensor and servo within Arduino. In this demo, you can put your hands over the ultrasonic sensor and the servo will start to move. So for our tool, we are using Arduino to connect Unity and Arduino. And we will prepare all the functions that the user is supposed to use in Arduino and put them into our tool. So the content creator can choose which functions they want to use during their own storytelling event. Also, they can make their own physical props like what we are doing with this green little bug. Also, we are exploring about audio visualization. It can collect voice from audience and make visual effects according to the volume. So in this case, the storyteller can let the kids make different kinds of noises in the event and let them see the pattern changes during they are making different noises in their projection. And now I'll pass it to Damien.
Thanks, Randy. So the documentation meant to help the content creator and storyteller how to use our tool and how to interact with the tool to make it more convenient and to let them understand all the features we create. And I divided basically into 3 parts. First part, we analyze the existing software that features we want to use in our tool. Like PowerPoint have really simple linear animation tool. Secondly, I record all the ideas we come up with from our brainstorming. But final and the most important part is the core functionality. We wrote the whole general process and all the details they need to know about our tools, make all the users, they will easier understand our tool features. So the next part, I will talk about our demo story. We use PowerPoint as a prototype to do the playtest. You will see some simple animation in those prototypes. and we'll show some dialogue to tell the story. So our playtest audience is the first-year grade student in the Highlands Elementary School. And all the students like our interaction very much. They react actively to all the questions we proposed, and they really want to take a guess about the next step of the story. And after the whole playtest, we housed the round table with the teachers in the elementary school, and all the teachers give us a lot of useful feedback. They recommend some books we should use in our interactive story. Besides that, they also give us some suggestions about storytelling and also share the challenges they faced when they tell the story to the student. For example, the student maybe will be too active to all the story things, so they have to control their emotion. So the next part, I will handle Laurie to talk about it.
Thanks, Damien. Now, our team, up to this point in the semester, has encountered a few challenges. Firstly, we are trying to design for multiple very broad target audiences, specifically the content creator and our event audience. And so accounting for different perspectives in how we develop our tool and how we go about designing prototypes has been a real challenge for our team this semester. Additionally, developing an event for 50 to 100 different people is a huge design challenge, especially when we're trying to make sure that all of those different interactions feel meaningful, and the museum would hopefully like to expand this to potentially be online or remote going forwards. And so making that kind of a possibility moving forward has been a challenge for our team as well. Next, we were given a very blue sky prompt to create a tool to tell an interactive story, or to facilitate telling an interactive story. And so our team spent the first few weeks of the semester really investigating that question, doing research as to what makes an interactive story fun, and how we could go about doing that. But that did eat our time in trying to actually move forward with the development process of the tool. So we got a later start on that actual development than we were hoping for. Next, we did have some of our external playtests delayed, meaning that we didn't get the data that we were hoping for as soon as we would like it, and we had to actually wait a couple of weeks longer than what we were hoping to kind of initially test our story and interactions. And finally, recently, we've been struggling a little bit with prototype stability, and particularly with the lag between Arduino and Unity. However, our team, although we feel we are a little behind in our development, we are optimistic looking forwards into the second half of the semester. Since we cut some of the features in our tool and developed tutorials for them instead, we believe that we can implement the rest of the features that we are hoping for in our tool. We're also going to focus really heavily on documentation of all of our different interactions and prototypes, such that we can hand that documentation over to the museum at the end of the semester, and they can use that kind of as a springboard going forwards. We would like to especially thank Anthony, Dr. Whiteman, and the Highlands Elementary School educators for hosting us and for facilitating that playtest with first graders. And finally, in summary, Team Story Studio is building a tool to facilitate interactive storytelling events at the Children's Museum of Pittsburgh. At the end of the semester, we will be delivering a beta-level tool along with prototype interactions, documentation, and a demo story showcasing our tool's features. Thank you, and we are now open for questions.
So just a clarifying question. So it's slide or page based in terms of how the different parts of the story are laid out?
Yes, so the idea is that the content creator could take the book that is like a physical book, or that we take assets from that book and put them into the tool such that it is almost as if you were reading a story digitally, right, but with like physical interactives that cause the page to turn or cause animations to change on the screen.
Do the interactives trigger on a page turn, or do you know what I mean? Or does the storyteller have to trigger turning them on, or how do those things get activated and change based on what page you're on?
The idea is that it's as flexible as possible. So those changes could either be triggered by like the audio visualization or like an audio cue. They could be triggered by a button press. They could be triggered by the facilitator advancing to the next page. All of those triggers and advances are kind of modular in our tool.
Two short questions. One, I just want to clarify. So in this space, you're going to have multiple stations and people working at different stations creating one story?
So it's the content creator is creating the digital content that you see on the screen, and the interactions are what trigger different events in that digital space. They're not creating the story in the space, if that makes sense.
Yep. And how do noise levels in the environment affect the total, 50 to 100 kids? Yeah, like how does that impact what you're doing?
That's a very, very good question. From our playtest with the students, it's kind of on the facilitator to actually kind of coordinate those sorts of interactions and make sure you have children's attention and that you can kind of lead that activity. It's still something that we're investigating, but that's what we've kind of learned so far.
So there are a lot of software solutions like Scratch, MakeBlock, companies based out of Pittsburgh. Why take the challenge of making your own tool?
So we actually did investigate a few of those other potential softwares. In particular, we looked at PowerPoint and iMovie, and we drew from those different softwares. But one of the potential goals moving forward is actually that our tool might be able to be used in workshops to kind of cause or like move the physical story into something that's digital. And so we really wanted to create something that was kind of streamlined for this specific purpose, which is why we've gone through a lot of iterations, simplifying our UI and what it means to incorporate those interactions so that the events would actually have an emphasis on the interactive component rather than just the digital component.
All right, that's time. Thanks, team. Okay, congratulations to all the teams. We're done with that. Actually, we'll go evaluate. And don't forget, the people who signed up, you